Hello and welcome to Arrow's What Is series. My name is Steve Horrobin and I manage Arrow's pre-sales team within Arrow's modern data center practice. Today we are going to be asking, what is an SSD? So we'll explain what that is. We're good with acronyms in the IT business, but it is a solid state device. So if we look again historically at where we've come from with storage devices, we go back to something called an HDD, which is a hard disk drive. And again, we'll do some scribbling, we'll do some drawing. If we look at a disk drive and we take the lid off it and have a look inside, then what we have is a large circular platter, obviously bolted into the system, and it's basically an oxide layer on top of some aluminium substrates, but it is a means of storing magnetic information. So it's not like a record. You don't have a start and a finish to it. All the data is stored in what they call tracks, and a track is completely cylindrical. Now obviously to read the information we then need a head, and then we need some sort of arm to hold the head, which connects to what they call an actuator. So within this device here, we can then move the head through the span of the disk surface. So that's previously how we stored data on hard disk drives. We have an interface coming in, all the data was coming into the disk drive and it was being written onto this spinning disk. Now, if you look at that, that's prone to a lot of failures. We've got a lot of components inside that device that are actually moving, and at some point it's going to fail. So what the industry has done over the last sort of few years, we've seen the introduction of solid state technology. So I think it first came about with things like memory keys. So we started to see, small memory keys, 1 gig, 2 gig memory keys, and they have been so useful that all of the senior people with all of their big pointy hats on have started to develop new memory technology, which has now grown and developed and been hardened to the point where the computer industry is happy to use it for enterprise class use. So what we've done now is we've migrated from this kind of technology over to, and this is going to be a fairly boring drawing, but we have an interface at the bottom. It's exactly the same type of form factor. So this could be 2.5 inch, could be 3.5 inch. This is exactly the same. So if we wanted to take out a 2.5 inch hard drive and put in a 2.5 inch solid state drive, it's very, very straightforward to do. Again, the interfaces tend to be the same as well. So it provides compatibility between storage controllers where they've previously been using hard disk drives, now to move over to the solid state drive. Now, if we look inside the system, there will be some form of controlling chip. Let's call it an ASIC. Again, the buzzword is application-specific integrated circuits, but basically it's the processor inside the hard drive that has some code on that is designed to do one specific task, and that's reading and writing data. Attached to that, as in a normal drive, there will be some cache. And that's like a pre-landing area where we can write data to and read data from. But beyond that, then it is just a collection of silicon chips. I'll try and draw these in fairly quickly. And these are all chips based on NAND technology. Again, won't go into that, but we have as much or as many chips as we can inside the device, inside the case, to provide the capacities that we're looking for, similar to the old spinning world. As technology gathers pace, more manufacturers come on board, different types of manufacturing technologies developed, then we start to get the densities increase as well. So we're certainly getting to a point, a tipping point people call it, where some of the hard disk drives are now being moved over to solid state drives, And I'll give you some sort of ideas and comparisons of capacities, and you'll get the idea of what we're talking about. So when we look at the 3.5 inch drives, they were measured on what they call revolutions per minute. So that's basically how fast the drive spins. So there's 5400, 7200, and then when we went into 2.5 inch drives, we were able to get that up to 10,000 RPM and also 15,000 RPM. This is where they basically hit the limits of physics. It wasn't possible to create a spinning disc inside a case faster than 15,000 RPM, so it never got any faster than that. But some of the lower speeds and the higher capacity drives, because of the 3.5 inch form factor, we were able to get some very large drives in there. For example, 1 terabyte, right the way up to today, I think we're looking at 26 terabytes in the largest 3.5 inch form factor drive. So quite substantial. A lot of information in a very, very small form factor. The 2.5 inch drives went through a different kind of process, really. So they were 300 gigabytes, 600, 900, 1.2. I think the highest I've seen there is about 1.8 terabytes. But you can see again with the developments here, it was more on speed and transfer rate than capacity. So the 3.5 inch drives have certainly gained higher capacity, where the smaller drives are faster in terms of transfer for the IOs per second that we're getting out of those that type of technology. When we move across onto the SSD drives, the revs per minute doesn't count because there is no spinning technology, there's no spinning drive inside a solid-state drive. It is purely solid-state technology. It's just purely chips, silicon chips inside there. But what we have from a 2.5 inch form factor point of view is some very high capacity drives now. So we start at 1.92 terabytes. We move on from there to 3.84, 7.68, 15.36, and I think there's 30.72 as well also available. So you can see some very, very high capacities in the 2.5 inch form factor drives. The 3.5 inch, we don't see 3.5 inch solid state drives. Okay, so they have generally stayed with the spinning disc technology that we've had over here. But as you can see now, in 2.5 inch, we're getting up to 30 terabytes, where on the 3.5 inch, that's already at 26 terabytes. So the 2.5 inch now on capacity on solid state has passed what we can get on the 3.5 inch in a spinning type drive. The spinning drives are still available and are still used, basically because of a price point. They offer a lower cost per gigabyte compared to some of the solid state drives. They still do demand a premium, I'm afraid. So we are going to see these drives available from a solid state point of view for the future. There will be more capacities that will come along. We've seen those already mentioned in the press articles. And then for the spinning drives, we will see these still used, but basically for applications where they need a high capacity, but not necessarily the fastest access speeds. So slow access, high capacity. So I hope that's given you a little bit of understanding as to what a solid state drive is. Again, this has been one of Arrow's What Is series. I'm really grateful to be able to present this to you, and I look forward to seeing you on the next video. Thank you.